Hello, welcome back. We're going to be working on our last type of factoring that we will be doing for this semester, and that is looking at what to do when we have two terms, and those two terms are perfect squares that are being subtracted. And so this is called factoring when you have a difference, that means subtraction, of two squares. So I thought that it might be helpful for us to, first of all, know what perfect squares are. So a perfect square is when you take a number times itself. For example, I'm going to start with 3. 3 times 3 gives us 9. So 9 would be a perfect square. 1 times 1 is kind of unusual. It gives us 1. 1 is a perfect square. 2 times 2 gives us 4. So 4 is a perfect square. And we could continue on with this table. 4 times 4 would give us 16. So 16 is a perfect square. 5 times 5 is 25. 6 times 6 is 36. All of these numbers that I'm writing are perfect squares. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. So the more that you can recognize these types of numbers, the better that you will be in recognizing this type of factoring. So we'll take a look at 4 examples. It's a rather short lesson today. I do have a formula for us, and the formula says that if you have two perfect squares that are subtracted, so here's how they start. To get the parentheses will be the square root of that first term. So in other words, the square root of 9 would be 3. The square root of 16 would be 4. So you would use the square roots and have a parentheses with addition multiplied by a parentheses with subtraction using their square roots. So we'll look at example number 1, and I'm going to go ahead and label things for us that we do have a form a squared, and then we do have subtraction, minus, and we have another perfect square, b squared. Now I might make mention about variables. Any variable that has an even exponent is a perfect square. So if they're numbers, they're going to be in your chart that we just made. If they're variables, they're going to have an even exponent. So we know that we can apply our formula because we have this a squared minus b squared form. So the work that you'll show is I'm going to have you identify a and b. So a would be the square root of the x squared in this problem. And the square root of a variable squared is just the variable without the exponent. So our a in our formula is going to be x. Our b in our formula is going to be the square root of the 25. And so the square root of 25, you can look at your chart. The 5 times 5 is 25. So the square root of 25 is 5. And so then I'm going to write our formula so that we can plug into it. Our formula is that we'll have a plus b and then a minus b. And so we'll make our final answer then, follow that pattern. You could go ahead and set up your two parentheses, one with a plus sign in it and one with a minus sign in it. And then the A, which is our X in this problem, will go first in each parentheses. And the B, which is the 5 in our problem, will go second in each parentheses. And there you have the factored form. Remember, factoring, you want to restore the parentheses. You want to put the parentheses back in the problem. If we were to multiply x plus 5 and x minus 5 together, we would get x squared minus 25. So this is the factored form of x squared minus 25. All right, so let's take a look at your second problem. On your second problem, we have 4m squared. So the 4 is a perfect square, and your m squared has an even exponent. Your 49 is also a perfect square, and we have subtraction. So we've met the conditions to be able to factor it using our formula. So we'll look at A first of all. So A is going to be the square root of 4m squared. So in other words, what times what would give you 4m squared? That's going to be 2m. And then your B is the square root of 49. So you can use your table, or you can also think what times what would give you 49. That's going to be 7. So I'm going to write our formula again so that you can see this is what we're using. And then I'll set up for my answer my two parentheses, one with a plus, one with a minus. The A in this problem is 2m. That goes in the front part of each parentheses. And the B for our problem is 7, and that goes in the back part. So 2m plus 7, 2m minus 7, those would multiply to give us 4m to the second minus 49. So those are your first two. I'm going to clear the screen and we'll look at your last two examples. Now, for your last two examples, I've written on your notes paper as a hint to factor out a GCF, or a greatest common factor, first. So you may wonder about that 80 v to the second minus 45. The 80 is not a perfect square. It's not in your chart up above. Neither is 45. So when that happens, you need to think, is there something that I can divide out of each one of those? Well, both of these numbers would divide by 5. And so 5 is our greatest common factor. Remember that we write the 5 on the outside of a parentheses. Then we do the dividing. So 80 divided by 5 is 16, and we still have v to the second, minus 45 divided by 5 is 9. Now, these values are in our table. But before I continue on with this, I'm going to encourage you, once you divide out a common factor, to go ahead and write that common factor in your answer blank so that you don't forget it, because that common factor does become part of your final answer. All right, so now we'll go back and notice that 16v to the second is our a squared, and 9 is our b squared. So we do have our formula satisfied. So the a is going to be the square root of 16v to the second. So multiplying to give you 16v to the second would be 4v. And then your b we'd have the square root of our 9. What multiplies to give us 9 would be 3. So using our formula of a plus b times a minus b, we'll go ahead beside our greatest common factor, set up our two parentheses, and then fill them in. So the a would go first. We'll have 4v in the front spot of each parentheses and 3 in the back spot. So 4v plus 3 and 4v minus 3. And then remember, you'll need that 5. So if this is an Alex assignment for you and you tend to be missing it, look to see, did you remember to type in the greatest common factor if you had to divide one out? All right, and then your last example, again, looking at 32. 32 is not a perfect square, and the a to the third is also a problem. It's not an even exponent. So hopefully we can divide out a common factor. Well, we can divide both of these not just by the number 2, we can also divide them both by a. So we're going to divide by 2a. And so we'll write that 2a in our answer blank. I'm also going to write it 2a and then do the dividing. So start a parentheses to get 16 and then a to the second. Remember that you subtract your exponents. Minus, now 2a divided by 2a. I have to have a placeholder there. So the a's cancel, but the 2 divided by 2 is a 1. You must have that 1. And both of those are perfect squares. The 16a squared is a perfect square. The 1 is in your list. 1 is a perfect square. And we have subtraction. So we'll set up and find out what our a is. So a is the square root of 16a squared. And so that's going to be 4a. And then our b is the square root of 1. And 1 times 1 is 1, so it's its own square root. Now we'll write our formula of a plus b and a minus b, and then go ahead and beside your greatest common factor for your answer blank, set up your two parentheses, and the 4a will go in the front of each one of those parentheses. And the 1 will go at the end of each one of those parentheses. And so you'll have 4a plus 1, 4a minus 1, and then all of that times the 2a for your final factoring. So it's a short lesson, not really a difficult one, but you do need to look for common factors and be sure that you do the square roots of your numbers in your original problem. So good luck on homework 9. It is an Alex assignment that you'll need to show this type of work for.